Hello dear visitor. In this video I'm going to demonstrate how a simple web page is implemented using my Projectional data structure editor called ProjecturEd. This is my hobby project for a long time now, and I think it slowly evolved to a point where it's worth looking at it. I'm not going to read out the text you see in this document. You can just stop the video anytime and read it yourself if you want to. I'd like to focus on demonstrating certain features of the editor instead. So first of all, let me stress that the document you see here is not just style text. It's a complex data structure that's just projected to the screen as style text by a complex compound projection. In fact, I can show you the underlying data structure by switching from the natural notation projection to a generic tree notation projection. As you can see, this is a completely different notation from the previous one. This notation directly expresses the underlying data structure, showing every minute detail of the objects. The red text specifies the type of the objects, the cyan text specifies the slot names of the objects. The rest specifies the slot values, and the whole notation is recursive. While this notation seems to imply that the document must be an object tree, but it's not the case. It's really an unrestricted graph of different kinds of objects. It may contain circles, and it doesn't have any special purpose parent reference. As you will see in this video later, the very same object may be easily present at multiple locations. In other words, objects may be referenced by multiple objects. Now let's look at the content. You might notice that the topmost green text is the title of the book. It was written with a large red font in the natural notation. The first chapter starts just below the title, and if I scroll down a little bit more, you'll see the underlying data structure of the first paragraph. The style text consists of colors, fonts, and simple strings. Well, I'll come back to the generic notation later, but now let's switch back to the original projection that gives us back the natural notation. So what's a projection after all? In short, a projection defines two small distinct algorithms called a printer and a reader. In other words, it's a bidirectional mapping between the input and output document data structures, including selections and document changes. There are different kinds of projections, such as primitive, compound, generic, and high-order projections. The most important thing about projections is that they can be combined to be able to handle really complex documents. So if you are interested how these lazy and incremental projections work internally, then visit the website of the project at ProjecturEd.org. Now let's do some basic editing. I start with selecting the first character of the first chapter's title with the mouse. When I click there, the combined reader of the editor's compound projection transforms the mouse click gesture into a change on the document. This is really a complicated process in general, because the individual projections have to play together nicely to achieve this goal. In fact, there's a text-to-graphics projection somewhere in the editor's compound projection. The text domain document knows how to represent a pure text selection, and the printer of this projection knows how to transform it to the graphics domain. Besides, the reader of this projection knows how to map gestures to basic text navigation and text manipulation. Of course, it's just one part of the process, because there are quite a few other projections involved. For example, before I continue with editing, let's say I want to focus on the first chapter and just forget about the rest of the document. Luckily, there's a pretty simple special projection called focusing that just happens to do this. Simply speaking, the printer's output of the focusing projection is some part of its input determined by a path, and the reader simply maps back the changes applied to the selected part to the whole. Now I delete the whole word, just like in a normal text editor, but in this case what actually happens is that the string in the title slot of the chapter object is replaced with an empty string. As you can see now, there's a pale placeholder that is supposed to help the user fill in the title of the chapter. In fact, this text is not in the document. It's put there by another projection that transforms a chapter into a tree node. This tree node allows nesting small text fragments into each other, annotated with delimiters and separators. Now I switch back to generic notation to show how the underlying data structure looks like. Notice how the selection remains at the same location within the title. That's because we actually see the same document with the same selection, just using a different projection. Now let me switch from displaying the last three gestures feature to displaying the current selection. If you look at the bottom of the screen, you will see the current selection transformed into a human readable string. In general, the selection is a path interpreted on the document that is being edited. The current selection says it refers to the zeroth position of the title of the first chapter of the book within the scroll pane, which is the document that is being edited. Let me type in the original title of the first chapter. The title was Introduction. You can follow how the selection changes at the bottom as I type. At this point, you may be thinking about whether it's possible or not to navigate around the document using this notation, just like in normal text editor. Well, the answer is yes. It is absolutely possible, and thanks to the combined nature of projections and data structures, the editor is fully able to follow what is selected in the original document. Okay, now that I moved around a little, let's switch back to the natural notation and see the changes reflected in the title and the selection. Now I'm going to remove the focus from the first chapter and return to the whole document. But before doing so, let me show you that it's possible to focus on a single paragraph. In fact, as you will see later on, focusing is possible on any kind of object. For example, you can even focus on as small a thing as a single XML attribute within an XML element. So far, I only used the text selection that is provided by the text domain and the related text-to-graphics projection. But this example also uses another quite generic domain called a tree domain. In fact, there's a compound projection involved that transforms tree nodes nested into each other into a flat text. The tree nodes may have opening delimiters, closing delimiters, and separators. You'll see how this is used when I get the JSON, XML, and programming language constructs. The tree domain and the tree-to-text projection provides us with a tree selection. I can simply turn the current selection to a tree selection by pressing Ctrl space. Notice how the description of the current selection follows as I move around in the document. For example, it gets longer as I move deeper in the structure, and it gets shorter as I move outwards. Well, now that I've finished with the first chapter, I use another generic feature of the tree domain, namely that it allows me to collapse the tree nodes. Okay, the second chapter simply describes the task that is implemented in this example, and the third chapter gives an overview of what is included in this document. I'm just going to show them so that you can read them if you want to, but after that, let me just collapse these two chapters and go on to the more interesting ones. Let me talk a little bit about the web page that is implemented in this example. It's a very simple HTML page that uses the Google JavaScript API to display a pie chart that is similar to this image. To make the example more complex, the pie chart downloads its data in a separate HTTP request in JSON format. The web page also includes a trivial style sheet. As you will see, all of this is part of the document and is implemented in a single Common Lisp function in the server. Actually, the function can be compiled and executed within the editor. The next chapter contains a table that summarizes the URLs that will be processed by the web server. Let me show you the underlying data structure of the table. Again, by switching to the generic notation, but this time I'm doing it in line, only changing the notation for this particular chapter. As you see, this chapter contains a paragraph and another one with a table. The table contains rows, and rows contain cells, and cells contain other stuff as usual. Well, this table actually appears in two separate places in the document. At first, it appears in this chapter in graphical form, where cells have graphical line borders around them. And as you will see later, it will also appear in the Common Lisp function as an automatically properly formatted text table in a comment section. Now we have arrived to the implementation of the web page. The first thing I want to show is that the HTML content in this chapter is not surprisingly not text. So again, I switched to the generic notation, but this time only for the ID attribute of the pie chart's div element. It's very interesting how the generic notation gets in line within the XML syntax, This phenomenon automatically falls out from the recursive way of transforming the XML document to a nested tree of text. From the editor's point of view, there's actually no difference in transforming the XML document to the XML syntax or to the generic notation syntax. They play nicely together. In fact, this is a requirement to be able to mix different domains in the same document, as you will see when we get to the server-side Common Lisp function. I can pretty easily navigate around with the cursor. I can even delete the value here and switch back to the domain-specific notation. You see the pale placeholder appears here similar to the chapter's title. So let me type back to the original value pi. But of course, the development is part of something bigger, namely the HTML web page that will contain the pie chart. So let me scroll down a little bit so that you see the development embedded into the HTML page. If I start editing the ID attribute value again, you will see the other occurrence changes automatically. That is also true for the attribute name. Just like in the attribute value, the attribute name is also turned into a pale placeholder to help the user type in a text there. Let me switch to generic notation for the whole development now, so that we see that the XML attribute is really changed. And let me type back the original values here with ID and pi. And of course, the other occurrence changes automatically, and I can even delete this stuff here, and you're not surprised that the other representation changed. Actually, the notation change is implemented by a higher order projection called the alternative projection that is parameterized by multiple other projections. So this alternative projection simply allows the user to select one of the parameter projections to be applied to that part of the document. So that's what I'm doing when I'm switching between the generic and the domain-specific notations. Another interesting thing I want to show you is that the focusing projection does not only work for the chapters, but it works for actually any kind of object. So if I start focusing here, what I get is the XML attribute itself. And if I start going upwards, I'll get more and more of the context. So the first is the div element, and then the body element, and the whole HTML page. And finally I get to the whole chapter. So let me continue a little bit more editing. Let's delete this last script element here and retype it. You can follow how I retype the elements using the special key bindings provided by the XML domain. The editor is very context sensitive. A more interesting example is how I can retype the body element, and that's because the body element not only contains a title, pie chart demo, but it also contains a div element. And as I type, I suddenly realize that it's supposed to be the same div element than the other one at the top of the screen. So how am I going to do this? And in fact, there's an extended copy-paste behavior that I call note and paste. So I can note this object and paste the very same object in place of this other div element, so it happens to be displayed at two separate places. So as you can see, now they are the same objects. Now that I've finished, I can go back to the whole document and collapse this chapter. Next chapter contains a pretty simple style sheet. The interesting part is in the second half of the chapter, which shows the very same style sheet transformed into a Common Lisp program. Well, this program writes the style sheet into a string stream when it is run. You might notice that the program structure is pretty similar to how the style sheet syntax elements are organized. That's of course is not a coincidence, but a result of applying a pretty generic projection to the output of the style sheet and parser. In general, the projection produces a Common Lisp program that writes the syntax into a stream when it is run. As you will see later, this projection is also useful for other domains such as XML, JavaScript, or a combination of them. So, of course, it's not a surprise that the two represents the very same object. So if I edit the selector of the rule in a Common Lisp program, then these changes will be automatically reflected in the other notation. Finally, I want to show you another representation of the same program at the end of this chapter. This program is produced by another projection that merges the stream write operations into a single one. It's like a poor man's partial evaluator, but remember this projection because we are going to use it in the following chapters in more complicated examples where actually not only constant parts are merged. So now that I've finished with this chapter, let me close this. The next chapter contains the JSON data that will be displayed in the pie chart. The format of this data is defined by the Google JavaScript API. The first part here defines the table header, then I show the first row, and the rest of the rows, and finally the whole table here. What's really interesting here is that the JSON table contains a small Common Lisp program embedded into it. This program is supposed to compute the number of hours that is left to sleep per day. Now let me change the number of hours I work because that's 11 is simply not true. Please notice how the other occurrences of the same number also changes as I edit. Now there's another problem in this table, namely that today nobody watches TV 2 hours a day. So let's just replace it with browsing the internet or reading fuel. But before I edit the table, I'd like to tell you that the rows in this table are sorted by a sorting projection based on the label. So as I'm going to edit the value, it will just move around to keep the table sorted automatically. Let me do some more editing here. Okay, just put a selection here. I just copy this object and then let me delete this entry and retype it. It was calls and then an array, an object, a label, task, and then new entry with type string, and then another object which I can paste the previously saved one. So I think that's it. I can close this chapter. The next chapter contains the JavaScript program that creates the pie chart in the browser after the page has been loaded. Of course, the program itself is not text, but a complex data structure that is projected to the screen as text. Let me switch to generic notation to show you how the data structure looks right now. For example, for this function call. In fact, the current JavaScript domain support is pretty basic, so I would rather go on to the following chapters after just giving a brief overview here. Okay, let me do this. The next chapter contains the error page that will be shown when the requested URL is not known by the web server. The interesting part is how a small Common Lisp program is embedded into the HTML page. This small program is supposed to write the path of the HTTP request into the error page. Notice how the code also contains a comment that includes an image. In the second part, you can see how the error page will be written to the network stream. Well, the merge program here is really interesting because due to the dynamic nature, the dynamic part that was included in the HTML page, it becomes a little bit more complicated. In fact, this chapter uses the very same projections that we have seen in the style sheet chapter. Now let me change a few things here and there to give you a feeling how editing works here. So let's delete a few words. Like this part contains not just a trace amounts of, but let's say it contains Lisp, you know. And then what if we delete this variable? And you can see here up at the upper part of the screen that the other occurrence also changes. You know, I type it back so that it keeps its name. But what if we write like, you know, we are very sorry that the page is not found. Now I think we reached the point where we are going to put together all the pieces in the server program. So let me just, you know, collapse this chapter 2 and show you how the server program looks like. The first part just gives you a quick overview by using a special projection that represents alien non-Common Lisp parts with a simple string in the if letter, as you see here. The second part shows the very same Common Lisp function with a projection that displays all content in its natural notation. As you can see, the server function contains an ASCII table, HTML, JSON, CSS, JavaScript, and so on. In fact, it contains all the pieces that we have seen so far. And of course, it means that if we edit any part here, I'm really going to edit the very same part that was already present in one of the preceding chapters, and vice versa. And what's really interesting here is the third part, because that's the one that is actually fed to the compiler. And as you can see, it's pretty efficient because it just writes big string constants to the network stream interleaved with the dynamic parts which are left unchanged. Let me show you how navigation selection works in this mixture of various problem domains. For example, tree navigation works just out of the box, as you can see here. And that's because from the editor's point of view, there's not much difference in nesting a JSON object into a JSON array or into a Common Lisp function. It all just depends on what kind of compound projections is configured and how this projections compose. And this is how mixed domain selection is represented. I would also like to show that delimiters are not part of the document. In fact, I can simply turn off displaying the delimiters, which results in a somewhat weird but still editable syntax. I do this for the tree leaves first, and then also for the intermediate nodes. But let me enable this again. So let me just compile this function and go to the last chapter. Finally, we've got to the point where I can actually run this example. I'm going to run it within the editor process simply by starting an embedded web server. But before doing so, I just do a quick look at the generic notation to show you how Common Lisp program is stored. So let me select this global variable here and switch to generic notation. If I scroll down a little bit, you can see the special variable definition here, and the value is an application which has, you know, the parameters that you've seen before. Here's the port, and then the handler function. Let me edit something in this program. First switch back, and then I'm going to edit the web server variable name in the generic notation. Let me add the word web here. As you can see, when I switch back to natural notation, the variable name is automatically changed in all occurrences, here and here. That's because the variable name is only stored once. In contrast to text editors, a structured editor uses direct references to a variable declaration where the name is actually stored. So as I revert the changes, you can see how the variable references get updated automatically. Let me show another interesting feature directly related to Common Lisp. In Common Lisp, symbols are organized into packages. Package has a unique name that is often used to qualify the symbol to avoid ambiguity. Unfortunately, just by looking at the program, it's not always clear which symbol comes from which package. But in a Projectional editor, it's pretty easy to have a switch that turns displaying the fully qualified symbols like this. And of course, editing is still possible. Okay, now I think I should really run this small example. At first, I'm going to compile this function that deals with the web server internals and data structures. This function calls the main service function that we called process HTTP request in the previous chapter. Then I define the server as a global variable by running the second program here. And finally, I just simply start the web server by running this server program. Okay, now let's switch to the browser. The web server is supposed to be up and running now. Let me show you the individual pieces in the browser one by one. First, here is the trivial style sheet. Then here's the JavaScript that's supposed to build the pie chart in the browser. The third is the actual data in JSON format that is displayed in the pie chart. We shouldn't forget about the arrow page that we added. And finally, let me show you the complete page in the browser. Well, I think that's it. I hope I didn't waste your time and you enjoyed this short demonstration of ProjecturEd as much as I enjoyed working on it. Thank you for watching.